Today we are going to begin lesson 3.4. Lesson 3.4 is going to have us use properties of special segments to solve problems. So we've got some vocab. We have a word called median. A median is a segment drawn from any vertex of a triangle to the midpoint of the opposite side. So a segment drawn from any vertex. Well, remember, a vertex is one of the angles. So I'm just going to draw a triangle. I'm going to call this triangle ABC. I'm going to draw a segment from vertex A. So up here at the top, I need to draw a segment down to the midpoint of the opposite side. Well, segment BC is opposite angle A. So here's my midpoint. I'm going to call that point D. Okay, a midpoint is going to divide a segment into two equal pieces. And so when I connect A to D, then in this picture, segment AD is a median. Okay, so essentially a median bisects a segment, but it has to start at a vertex and it goes to the midpoint on the opposite side. So technically, if I started from vertex B, I'd have to create a midpoint over here on the segment AC, and then I would have a median. If I call that point E, I would have the median BE. So I technically have three medians in a triangle. Okay, the next vocab word is altitude. An altitude is a segment drawn from any vertex of a triangle perpendicular to the opposite side. So the fact that we're talking about perpendicular means that we are forming right angles. So I'm actually going to sketch a couple of pictures here. So here is a triangle. I'm going to call this triangle EFG. All right, if a segment is drawn from any vertex perpendicular to the opposite side, I'm just going to have my vertex up here at E. So then I have to draw perpendicular, which then forms right angles. So it doesn't necessarily have to go to the middle of the segment, okay, but it does have to be perpendicular. So you have to have it look like an upside down T. If it doesn't look like an upside down T, then you're not going to have right angles. So in this particular picture, if I call this point over here H, then I would say that segment EH is an altitude. Okay, I am going to draw another triangle here. I'm going to draw a triangle. Let's call this triangle JKL. And say I wanted to draw an altitude from the vertex at J. Okay, if I wanted to draw something perpendicular, I can't go from J and actually have it touch the segment KL this time, because then it won't form that nice T. I actually would have to draw it so where if I was to extend that segment KL, it would form a right angle. So we have to understand that sometimes altitudes are actually going to fall outside of the triangle in order to actually form that right angle. So my top picture, the altitude is inside because I could very easily draw an altitude, but not in the bottom one. Okay, so sometimes altitudes are inside, sometimes they are outside. The next word we have is perpendicular bisector. It is a segment drawn from the midpoint of the side of a triangle and is also perpendicular to the segment. So I'm going to sketch a picture. I'm going to call this triangle MNO. And say I wanted to draw a perpendicular bisector from the segment NO. Okay, it's going to start at a segment because it starts at the midpoint of one of the sides of the triangle. So a midpoint is going to divide that segment into two. I'm going to call that point P. So P is the midpoint. And then to make it perpendicular, hopefully we noticed that we would have to go straight up to form the right angles, which means that in this particular picture, it's not going to go to an angle in my triangle. Sometimes it might, but sometimes it won't. So in this picture, if I call this point up here Q, I would say that it's the segment PQ, which is a perpendicular bisector of the segment NO. Okay. All right. If I take a look at angle bisector, this should be a review because we've talked about angles being bisected in the past. It's a segment drawn from any vertex of a triangle and divides the angle into two congruent angles. So if I was to sketch a picture, let's call this triangle RUS. If I want to have an angle bisector, let's say I want the angle to be angle R that's being bisected. Well, then when I draw that segment, I've got my two angles up here at R being congruent. Let's call this point T. So I would say that the segment RT is the angle bisector of angle URS. Okay, so those are our four special segments: medians, altitudes, perpendicular bisectors, angle bisectors. So today we're going to focus on some algebra problems and using those. So if we have this picture right here, I would suggest that you draw it. We've got the segment XZ is a median to the segment WY. That's something that we're going to be able to mark up. If we think about the vocab word that we just talked about, a median is going to be a segment drawn from any vertex to the midpoint of the opposite side. Well, the vertex that it started at was X. It went to Z. Z must be the midpoint. So to be a midpoint means that it's dividing that segment WY into two congruent pieces. If I know that WZ is represented as 2x plus 7, I can mark that in my picture. ZY is represented as 4x minus 3. And then it says that the segment XZ, which is our median, is 3x minus 1. They want us to actually find the length of that median. Well, based off the picture and our markings, hopefully we're okay with noticing that I've got two segments that are congruent. Congruent means equals. So I get to take 2x plus 7 and set that equal to 4x minus 3. So I'm going to subtract the 2x so I can get the x's on the same side. That'll give me 7 to now equal 2x minus 3. I'm going to add 3 over to the left to combine those numbers. That gives us 10 to equal 2x. And then to get x, I'm going to divide by 2. So we get a value of 5. Now remember, that's not my final answer. I didn't ask for x. I asked for the segment length of the median xz. So segment XZ is 3x minus 1. So 3 times 5 minus 1 gives us 15 minus 1. So it looks like 14 is going to be that length. Let's take a look at another one. So once again, I would suggest that you sketch the picture so then we can mark it up. So we're told that the segment MR is an altitude to the segment NP. So remember, an altitude is a segment drawn from any vertex of the triangle perpendicular to the opposite side. Hopefully we're okay with M is the vertex. That means that R down here is going to be where we are forming our right angles. So I've got two right angles in this picture. They both happen to be inside of the triangle. I know that the segment NR is x minus 6. I know that the segment of PR is 1/2 x plus 3. We are told that the angle MRP, so if I follow the letters, MRP is this angle right here, is 5x. They want us to figure out if that segment MR is also a median. Now, to be a median, remember that means that R has to be the midpoint because we would be bisecting the segment NP. I cannot assume that. There's no markings with those segments. I don't know anything about those segments. However, the one thing that I do know about this picture is that I've got a right angle, and I also know that that right angle is represented as 5x. Well, remember, a right angle is 90 degrees. So I get to set 5x equal to 90. And that's how I'm going to start then solving for x. Well, 90 minus 5, or not minus, but divided by 5 to get the x by itself is going to give us x equal 18. Now that I have that, I can substitute 18 into the segment NR and into the segment PR, and we can determine if those two segments are congruent. If they are, that means that the segment MR bisected the segment NP, so we do have a median. If they are not congruent, well, then we don't have a median. So, when I substitute in 18, I'll have 18 minus 6 for the first segment, and I want to take half of 18 and add 3 to the second segment. Well, 18 minus 6 is going to give us 12. Half of 18 is 9. 9 plus 3 is going to give us 12. So the fact that they both equal 12, is segment MR also a median? Yes. Segment MR is a median. And that's only because after we found X, we were able to see that those two smaller segments were congruent. But don't set them congruent to begin with. We cannot assume that. All right, if you sketch this next picture, we are going to be looking at AD is an altitude and it's an angle bisector. So we've got two special segments here. If it's an altitude, remember, an altitude forms right angles. Hopefully we're okay with A is where the vertex is. D is where then the right angles are being formed. So I get to mark that in my picture. It's an angle bisector at the angle that it starts. So since it starts at angle A, that's going to be where I have my two smaller angles congruent. We are told that angle BAD is represented as 3x minus 6. Angle CAD is x plus 20. Because we're trying to find the measure of angle B, we have to figure out what x is first, and then we'll talk about our relationships of angles and inside of a triangle. So the fact that we know that both those smaller angle A's are congruent because there's an angle bisector, well, congruent means equal. So I get to set those two angles equal to each other. That means I'm going to subtract the x to combine those x's together. That gives me 2x minus 6 to equal 20. I'll add 6 over to the other side. That gives me 2x equal 26. And then I'll divide by 2, and I find out that x is 13. Now, what I can do is I can find the measure of each of those small angles. So let's find the measure of angle BAD. Okay, that is by us taking 3 times 13 minus 6. Well, 3 times 13 is going to give us 39. When I subtract 6 from it, it's going to give us 33. So that's a 33-degree angle. So because we are asked to find the measure of angle B, and I don't know what that is, I don't have any expression, I'm going to look at this triangle BAD. I already know that there's a right angle, so I know that that's 90 degrees. We just found the measure of the angle BAD, so we know that that's 33 degrees. There is a relationship between angles and the triangle. We have 3 angles in a triangle, and 3 angles of a triangle will always add up to 180 degrees. So, in order to find the measure of the angle B, I'm going to be subtracting 90 and 33 away from 180. So once again, the reason why I'm using 180 is that all 3 angles will add to 180. So 3 angles of a triangle add to 180 degrees. So I'm going to subtract the 2 angles that I know. I'm going to subtract the 90 and I'm going to subtract the 33. Well, 180 minus 90 is 90. When I subtract 33, we find out that angle B is a 57-degree angle. Last problem. So once again, sketch the picture because we're going to be marking it up. We are told that the segment HK is a perpendicular bisector of the segment JG. So perpendicular bisector, there's two vocab words there. Perpendicular means that it forms right angles. Hopefully we're okay that it has to be here at K where we have those right angles. It is also a bisector of a segment. It's the bisector of the segment JG. To bisect a segment means we are dividing it into two equal pieces. So now I'm going to mark up the rest of my picture. Angle HKJ, which is this angle right here, is 6y plus 18. We know that the segment KJ is 5x minus 7, and the segment KG is 2x plus 11. We are asked to find both x and y. So let's solve x first. Both of the terms with x are segments. Both of those segments are marked the same. Congruent means equals. So 5x minus 7 is going to equal 2x plus 11. I'm going to get the x's to the same side by subtracting 2. That'll give us 3x minus 7 equals 11. I'll add the 7 to the other side. So 3x is going to equal 18. Divide by 3, and we get a value of x to be 6. There's one of our answers. We also have to find y. The only expression with y is representing an angle. The angle that it represents is a 90-degree angle. So I get to set 6y plus 18 equal to 90. So I'm going to subtract 18 over to the other side. That gives us 6y to equal 72. I'll divide both sides by 6, and so 72 divided by 6 gives us 12. And there are my two answers. All right, so that's us using properties of the special segments to solve problems. Make sure you're sketching a picture, marking up your picture, and showing all of your work.